Hey everybody, here's your intro video to the derivative involving e to the x. In a separate video, I'll do a proof for it. But for this video, I'm just going to tell you that if you have the function e to the x, the derivative of that function is actually going to be e to the x. It's other than y equals 0, which derivative is also 0. This is the only function that this sort of special characteristic shows up. So the way that would look as for some examples, if you've got, let's say, y equals 3e to the x, we could take that derivative pretty simply. So this constant is just going to come along for the ride. So it'd be 3 times whatever the derivative of e to the x is, which is e to the x. Boom, done. It is that simple, believe it or not. But it can ramp up a little bit. Suppose you have y equals 5 e to the 4x. So same kind of start a little bit, because you have a constant involved. But look what happens this time. It's going to be 5 times the derivative of e to the 4x. Well, I gave you the rule just e to the x. Do you remember what we do when we have a thing that's not simply just x when we go to do our derivatives? When we have like a composition of functions. So we do need the chain rule here. So this is going to be e to the 4x, leave the thing alone, times the derivative of the thing, which is 4. So if it helps you, you could even do this and think of it that way. Remember when we did ones that look like, y equals sine of 4x, and we said, okay, what's the derivative? The derivative would be, well, cosine of the 4x, leaving the 4x alone, times the derivative of the 4x, because that was the chain rule. This is exactly the same concept. The derivative of e to the thing is e to the thing times the derivative of that thing, in this case 4. And we can clean that up. 5 times 4, of course, is 20, e to the 4x. We could even take a second derivative. It's just the same concept, just rinse and repeat. If I wanted the second derivative here, I would do the exact same thing. 20 e to the thing times the derivative of the thing. And that would be 80 e to the 4x. And that would be good too. Okay, so just got to remember, the derivative of e to the x is e to the x. But if it's not simply an x, you're going to need a chain rule kicker. All right, let's kick it up one more little notch here. Suppose we have y equals x times e to the x. So you got to remember some of your basic rules. We have the chain rule, of course, from the other example, but in this example, it looks like we kind of are stuck doing a product rule. So it doesn't really matter what order we do it in. So derivative of x is 1, leave the e to the x alone, plus leave the x alone, derivative of e to the x is e to the x. Now, if you're looking at an answer key, they may simplify because there's a common factor here. So that would be 1 plus x if we simplified it. But technically, this is the derivative, and those are some basic examples using the derivative for e to the x. If you're interested in the proof, feel free to watch the other video. Otherwise, just practice the rule and let me know if you have any questions. All right, see you later. I hope you guys are doing well.